Okay, let's go over the test. Um, the function is 4 minus x squared. Whatever the input is, we square it and then subtract that answer from 4. So if we put 2 in for the x, it says find f, or the y value, when x is 2. So we get 4 minus 2 squared. Now the minus is not squared, just the 2. So 2 squared is 4. And so we have 4 minus 4, which is 0. That pen is dying. Let's go to here. All right, so now we got to do -3. So we got to go put the -3 as the input. We're supposed to square the input, and then take 4 minus that input squared. So 4 minus the input of -3, and that negative is squared, that one's not. So -3 times -3 is +9, so we have 4 minus 9, which is -5. Now we're supposed to put a plus 3 in for the input. So this means we're going to have 4 minus the input, a plus 2, excuse me, and square it. Now, a plus 2 squared, several of you did this. You said a plus 2 times a plus 2. And this is totally correct to do. A times a is a squared, 2a, and 2a, and plus 4. So that's a squared plus 4a plus 4. And many of you did this correctly. A few of you didn't. But we're supposed to subtract this from 4. And this is where a lot of you messed up. It says subtract what you get. So all of this is subtracted. So it's minus the a squared. It's minus the 4a. It's minus the 4. So 4 minus 4 is gone, and we have negative a squared minus 4a as the answer. And so this is part C, and this was the part D. Find the slope of the secant line from going through what? At x equal 2, and when we put 2 in, we got 0. So we want to find the slope of the line going from 2, 0, and then when we put -3 in, we got -5. -3 gave us -5. So we're trying to find the slope between these. And the slope is the change in the y over the change in x, the rise over the run. 0 to -5, that's going down -5. 2 to -3 is going down -5. Also, -5 divided by -5 is +1. Or you can think of this as point number 2, and this is point number 1, and do y2, y from the second point, subtract y from the first point, over y from the x from the second point, minus x from the first point, and that gives you -5 over -5, which is 1. This is using the formula y2 minus y1, the difference in the y's, the change in the y, the rise, over x2 minus x1. Now you could have called this point number 2 and this number 1 and done the formula, and you would have gotten +5 over +5, which is still 1. All right. we're supposed to put 1 into f. Now, that was 4 minus the input, which in this case is 1, and square it. 1 squared is 1. 4 minus 1 is 3. So now we have to find f of 3. And so we put in, this is f of 1. That's what this worked out to be. So now this is a 3, and so we got to put 3 into f again. So it's going to be 4 minus 3 squared. So that's 4 minus 9, which is negative 5. Now, if you were to graph this, and you could type it into your calculator, it's an upside down parabola moved up 4. If you plug it into your calculator, it's an upside down parabola moved up 4. And so it does not pass the horizontal line test, but it does pass the vertical line test. And since it only passes the vertical line test, to have an inverse, it has to pass both. Does this have an inverse? No. Doesn't pass both tests. Or another way to say that, it's not 1 to 1. 1 to 1 means it has passed both tests. It has to be 1 to 1 to have an inverse. Page 2. Excuse me. Page 2. The input for G is 8. We're supposed to find G of it. So we put 8 in there. So we get the square root of 2 times 8. 2 times 8 is 16, and the square root of 16 is 4. We're supposed to put minus 3 in for the x of k and figure out what the y is. K is in here, and if we put minus 3 in, it looks like it's 4. You follow that? Go to minus 3, up, and it says the y value for minus 3 was 4. This point is minus 3, 4. Now it says, what value of x will give us a f equal to 5? So we have 3x minus 4 equals 5. What had to be put in? So if I add 4 to both sides, I get 3x equals 9. Divide by 3, and I get x equals 3. This next one says put 2 in for the x. So 2 times 3 is 6. 6 minus 4 is 2. So f of 2 is 2. So then I got to figure out g of 2. So put 2 in here. 2 times 2 is 4. Square root of 4 is 2. So that is also 2. So I got to find h of 2. So I go to 2 in h, and I find out it's negative 2. Now I'm supposed to find h, putting in negative 3. Negative 3, h turns it to a 0. So that's 0. So now I got to find k of 0. So if I go to 0, k is, the y value is 1. 0, 1's on the graph. So this is 1. F inverse. That's switch the roles of, find F inverse. So if 3x minus 4 is y, the y value from F, and we're supposed to switch the roles of y and x, we get x equals 3y minus 4. Then if I solve for y, add 4 to both sides, and then divide by 3 to get y by itself, I get F inverse is x plus 4 divided by 3. Now, the other way to think about that, if you don't like that, is this function multiplied by 3 and subtracted 4. If we reverse the process, we have to add 4 to the input and then divide by 3. Add 4 to the input and divide by 3. We reverse the process. Now, h inverse, again, we're swapping y and x's for h, so it would be x and h inverse of x. So negative 3 went to 0, so now 0 will go to negative 3. 1 will go to negative 2. Negative 2 went to 1, so now 1 has to go back to negative 2. And 2 will go back to negative 1. And 3 will go back to 0. And negative 1 will go to 1. Negative 2 will go to 2. And negative 3 will go to 3. So we backed it all up. So that's this one. And what's the domain of h? What are the things that are where we know how to do in h? Well, it's only this set of numbers. So it's negative 3, negative 2, negative 1, 0, 1, 2, and 3. Those are the numbers that we know how to deal with to put into h. All right, this is f of x. What happened to this to make this? Well, everything got moved down 3. 1, 2, 3. 1, 2, 3. So everything's down 3. That's an outside thing. So it doesn't work on the x, it works to the whole thing. So it's f of x minus 3. The whole thing moved, all the y values moved down 3. What do we do to this to get that? Well, it's the same height, so it's not up or down. It's not squeezed or stretched anything. So this is just a movement. It moved it over 1, to the right 1, horizontally 1. So to go horizontal, it has to work on the inside. And to go, everything on the inside works opposite. So if I added 1 to this, it would move it to the left. But I have to make it go to the right, so it's x minus 1 on the inside. Work on the x first. So that's that one. Now this one, it went up 1 from here. It's up 1. So that's on the outside. So f up 1. Now it's not stretched or shrunk vertically. It's the same height. It's 3 squares high. 1, 2, 3 squares high. This is still 3 squares high, so there's nothing times the f, nothing working vertically. It's squeezed this way. And it's 2 away, and it goes to half away. So if it goes from 2 to a half, that's taking 1/4 of it. So we might think 1/4 x, but in reality it goes to, since it's inside, it does the opposite of what we think. So it's 4 times the x. Okay, now let's go to this one. The parent is y equal x squared. And I really hope that you know how to graph y equals x squared. 0 squared is 0. 1 times 1 is 1. 2 times 2 is 1, 2, 3, 4. And negative 2 squared is 4, and negative 1 squared is 1. I'm really looking to see that you know how to get those 5 points. 4, 2, 4, 1, 1, negative 1, 1, negative 2, 4. Okay. Now, in class, we talked about you could either do the stuff inside the parentheses or the stuff outside. We suggested doing the outside stuff first, and most of you did that. And when you're working outside, everything works like you think it should. So you normally multiply before you add. So we're going to do the -2, and we talked about the minus and the 2 being 2 separate transformations. So I'm just going to go left to right order. I'm going to do the minus. So that a minus vertically is going to take all the plus values and change them to minus values for the heights. So I'm going to move the line up here. The height of this is 0. This is 0, 0. Its height is 0. And so it's going to stay at 0. The height at 1 was 1. So now we're going to go to -1. The height of 2 was 4. So we're going to go to -4. The height at -1 was 1. So it goes to -1. The height at 2 was 4. So it goes to -4. So that flips it over the x-axis. Reflection or flip. That's the minus. Now we got the 2. Now the 2 is still on the outside, so it works vertically, and so it makes it doubles everything, doubles the distance it is from the x-axis, doubles the height. So I'm going to move this up here so I got enough room. This one's on the x-axis, so doubling 0 distance away from the x-axis is still 0. This is 1 away, so it moves to 2 away, twice as far. This is 1 away, -1, so it goes to -2. This one was 4 away from the x-axis, so it goes to 8. 1, 2, 3, 4, 5, 6, 7, 8. This was down 4, so we go down 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is working. This 2 on the outside is making things twice as far from the x-axis. So it's a vertical stretch by a factor of 2, twice as much. So the minus, the 2, and the 1 are on the outside, and the 1 is plus, so it's going to move this graph up 1. It does just like you would think it would. So I'm going to move the x-axis down 1 so I can move the whole graph up 1. So this is at 0 height, it goes to 1 height. This was down 2, so it's going to go to down 1. This was down 2, so it's going to go to down 1. These were down 8, so they're going to go to down 7. So we've lifted the graph up 1. And finally, we got a number on the inside. It's subtract 3, and everything on the inside works opposite, including the order of operation. And subtracting 3, we think would go left, but it goes right 3. So this point that's up 1 will go over to 3 over, up 1. The next one over is down 1. The next one over the other direction is down 1. And the next one over is down 7 and 7. So this is over 3 and down 7. Okay. And so this is right 3. So where did 2, 4 go? Well, it went to 2, negative 4, then 2, negative 8, then 2, negative 7, and then 5, negative 7. Next page. I tried to make this simpler, and some of you made it harder. Find out what happens when you put 5 in. Well, 5 is not between negative 2 and 5. It's equal to 5. So we got to use this one. So 5 plus 3 is 8. We use this equation. F of 0. 0 is between these two, and so y is, or f is 3. It says it's always 3 for the numbers between there and there. And for negative 7 is less than negative 2, and the y is equal to the x. The x is negative 7, so this is equal to negative 7. That's that one. All right, this one. When is it decreasing? Well, if we go left to right, it's increasing up to about this place. That looks like about negative 0.6 in the x, and it decreases all the way till x becomes about 0.8. So on this interval, it's decreasing. Then it increases until we get to 2. And from 2 to infinity, this goes towards negative infinity, but we don't look at that. We look at the x values. From 2 to infinity, this is going down. Again, when we're looking at the intervals, we're looking at the x values. From where to where in the x's is this going up or down? Concaved up. So it's got to be curving up. And that happens somewhere from about here to about there. And then it starts curving down. So it's concaved up somewhere around 0 or 1, 0.1 or 0.2, somewhere in there. I'll just put 0.1 is where it's changing from concave down to concaved up. You could have used 0, you could have used 0.2, something where it's curved up until about here, which is about 1.5. And we never include where it's changing. Now, the places where it changed in curvature are inflection points. So if I use 0.1 here, the y-coordinate that goes with 0.1 looks like it's about, minus 0.2 or 3 or 4. And the other place where it's changing, if I go to 1.5, it looks like it's -1. So where it changes curvature. Determine any local minimums. Well, the lowest place, there's one right there. It looks like it's about -2.1, something like that. That's that one. Find the inverse. Well, this is 9, 8. This point right here is 9, 8. So I'm going to graph 8, 9. So this point gets pushed over to there. Here's a nice one. 8, 2. We'll go to 2, 8. There's another one there. That's 7, 0. So that's going to go to 0, 7. This one is 5, -1, -1, 5. There's another one, 4, -2, -2, 4. Another one here, 3, -4, -4, 3. And down here at the end, it's 2, -10. So I go to -10, 2. And if I just kind of connect those, and the curve that this looks like, get something that looks like that. How high is the ball after 2 seconds? So we just got to put 2 in for the time. So it's -16 times 2 squared. That's 4 times -16. Plus 70 times 2. So that's 140. And -16 times 4 is -64. If we add those, we get 76 feet. Now, this one is a function that you give it minutes and it gives you seconds. So FM is the minutes. I have to multiply that by 60 and I get the seconds. So that's S given minutes, return seconds. M times 60 or 60M. Now, this function needs to get seconds. And if I want to make it take in minutes, then I've got to convert my minutes to seconds first before I put it into here. So it's going to be H of S of M. Give it minutes, turn them to seconds, and then put that in for the T in H. So I don't put the T in here. This becomes the T. So I get -16. If I were to finish this, T is going to be 60 times the number of minutes, and we'd square that. Then we'd go plus 70 times 60 times the number of minutes. And that would give us the height. I accepted this answer, and I accepted that answer. One or the other. Some of you did both. Probably should have given you extra credit.